Assalamualaikum and hi guys. So in this video you will learn about the application for the first order differential equation, which is Newton's law of cooling. So this is the mathematical model for the Newton's law of cooling, whereby T here stand for the temperature, A and K here is a constant, the small t here refer for the time, and TS refer to the surrounding temperature, room temperature, constant temperature or ambient temperature. Okay, so you have to be familiar with this name because this is the value that represent the TS. Okay, so before you want to solve the case study or the problem statement, you have to determine what is the value for the initial temperature, which is T naught. So naught here represent the time equal to 0, and TS represent to the surrounding temperature. T with the small of t represent the temperature at any time t. Okay, so by refer to this question, a bowl of soup had just boiled 100 Celsius is allowed to cool with a constant temperature. Okay, so we have here the words for the constant temperature is 20. So we know that our TS is equal to 20. So the 100 here is the initial temperature. Okay, so your T naught is equal to 100. The constant temperature is 20, and then after 5 minutes, so after 5 minutes, the soup has been cooled to 60 Celsius. So this one stand for the T5 is equal to 60. So by using all of this information, now we will substitute to the mathematical model in order to solve the question. So we start with the formula AE negative KT plus TS. So the first step is we need to find A by substitute T naught and TS. Okay, so our T naught is 100 and our TS is 20. So we will substitute the value to this formula. So T100, T naught is equal to 100 means that our small t is equal to 0, our temperature is equal to 100. So we will substitute this value to this formula. So therefore 100 is equal to AE negative K multiply 0 plus TS is 20. So therefore our A is equal to 80. So substitute back to the position of A. So you will substitute A equal to 80 to this position of A. So therefore your T will become 80 exponent negative KT plus 20 because our TS is equal to 20. So now the next step is find K by substitute. We have another temperature which is T5 is equal to 60. T5 equal to 60. So in this step means that we will substitute temperature at any time t. Okay, so in our case we have T5 is equal to 60, which means that our small t is equal to 5, our temperature is equal to 60. So now we will have 60 is equal to 80 exponent negative K multiply 5 plus 20. So our aim now, we want to find the value of K. So you need to simplify all these constants. So we simplify 20, bring to the left hand side. So it will become 60 minus 20, 80 exponent 5 K. So this one is 40 exponent negative 5 K. So now you have 80. Bring 80 to the left hand side will become divide. Okay, now we want to have the value of k. We want to know the value of k here, but we have the exponential. So how to eliminate the exponential? By applying ln for both sides. This one to eliminate the exponential. Okay, so apply ln for both sides. So ln 40 over 80 is equal to ln exponent negative 5k. So for this one, ln exponent negative 5k, it will become negative 5k because of the properties. Ln exponent negative 5k is equal to, so this negative 5k, we bring to the front, negative 5k ln e will become negative 5k. So now your right hand side ln exponent negative 5k will become negative 5k. So in order to get the k here, we need to divide with negative 5. So therefore k is equal to ln 40 over 80 divided by negative 5. So your k will become 0.138629. So we have too many decimal. So for this value, you will take at least 4 decimal places. So therefore your k is equal to 0.1386. So this value of k, you will substitute into the position of k. Okay, so the latest formula that we have update is whereby you already have your a, which is e is equal to 80e. So substitute to this position. So now our k is equal to negative 0.1386 t. Okay, because we have negative from here, we have kt. So even though our k is equal to 0.13, so when we substitute here, we still have the negative. So from this formula, now we will use this formula in order to answer the question. So determine how long for the soup to cool down to 22. So means that how long means that you have to find what is your t, whereby your soup is 22. So what is t when our temperature is 22 Celsius? Is it 22? Yeah. Okay, so now you have to substitute your temperature become 22. 22, 80 exponent negative 0.1386 t plus 20. So the same concept, you have to simplify all the constant. 22 minus 20. So this one will become 2 is equal to 80 exponent negative 0.1386 t. So this 80 to the left hand side, 2 over 80 e negative 0.1386 t. So in order to get the t here, we apply ln for both sides. So the right hand side will only become 0.1386 T. So therefore our T is ln 2 over 8T. Divide the whole thing with 0.1386. So we have the negative here, so you must divide with the negative also. So therefore our T is equal to 26.6153. So for this one, you can also take 4 decimal places, or you can take it T is equal to 26.62. So don't forget to write the unit here, because the time represent the minutes, so we write in terms of minutes. So both answer will be accepted. Okay, now we continue for the second example. In a murder investigation, a corpse was found exactly at 8 p.m. And then the detective measured the body temperature and found it to be 70. Okay, and found it to be represent our initial temperature. T0 is equal to 70. The next information is the body temperature again. So 2 hours later, it check, it become 60. So 2 hours instead, T2 is equal to 60. Now you want to know what is the room temperature. So the room temperature is 50. So TS is equal to 50. So by assuming the body temperature of the person before death was 98.6, what is time of the murder? Okay, so now we want to know what is the time the murder happened, whereby our normal temperature is 98.6. Okay, so now by using the same formula, T is equal to AE negative KT plus TS. We want to find what is the value of A. Okay, by substitute our T0 and TS. So now our T0 is 70. AE negative K multiply 0 plus TS is 50. So therefore our A is equal to 20. Okay, so once you get your A, substitute back to the formula. T is equal to 20 E negative AT plus TS is 50. The next one, we need to find the K. So find K by using T2 is equal to 60. So now your temperature is 60. 20 exponent negative K multiply 2 plus 50. So we want to know the K here. So you have to simplify all the constant. So first, 60 minus 50 is equal to 20E negative 2K. So 10 is equal to 20E negative 2K. 10 over 20 E negative 2K. Now we need to apply ln for both sides. Ln 10 over 20 is equal to negative 2K. So therefore our K is equal to ln 10 over 20 divide the whole thing with negative 2. So therefore our K is equal to 0.3466. Okay, so this one we take 4 decimal places. So substitute back to the position of K. You will have T is equal to 20E negative 0.3466 T plus 50. So now we want to know the exactly time of the person die, which is by using the normal temperature, you want to know the time. So now by using T is equal to 98.6, what is T? Okay, so substitute your temperature is 98.6, 20E negative 0.3466 T plus 50. 98. Okay, so the same thing, simplify the constant. 98.6 minus 50 is equal to 20E negative 0.3466 T. Two, 4, 48.6 is equal to 20E negative 0.3466 T. So to eliminate the E, okay, we have 20, so divide by 20 first. 48.6 divided by 20, E negative 0.3466 T. So by applying ln for both sides, ln 48.6, the right hand side will become 0.3466 T. So therefore our T is equal to ln 48.6 divided by 20, divide the whole thing with 0.3466. So you will have your T negative 2.5617 hours. Okay, because we are talking about hours. Okay, it's mentioned here in terms of hours. Okay, so our T is also in terms of hours. But now we want to know what time did the murder happen. Okay, so we have the information. The police found the corpse at 8 p.m. Okay, so we just imagine that this is our clock. 8 p.m. here. This one is 9, 10. This is 7, 6, 5. So at 8 p.m, the police found the body. Okay, so now we want to know at what time the person died. 2 hours. So negative 2.5617 hours before the police found. So supposed to be the person must be died before 8 p.m. because this is the time whereby the police found the body. So means that we need to reverse by 2 hours in order to know what is the exactly time the person died. Okay, so therefore 8 p.m. minus with 2 point. So from here we have negative 2.56. So we estimate our T is negative 2.56 hours. So we want to reverse by 2.56. So in order to solve this one will become 7, 60 minutes. So 60 minus 56 will become 0, 4. 7 minus 2 will become 5. So means that when we reverse by 2 hours, the exactly time the person died is at 5:04 p.m. Okay, because the police found at 8 p.m. When we reverse by 2 hours behind, it will become 5:04 p.m. So this is the time at death occur. Okay, so that's all for this video. Thank you.